Welcome to yet another exciting educational video brought to you by Vision Concepts Academy. So today, IGCSE Physics will be looking at using physics apparatus safely and recording observations accurately. That's our topic for this video. Now, we'll look at our objectives. At the end of the lesson, we'll be able to identify common laboratory apparatus and explain what each one is used for. Number 2 objective is to set up simple physics experiments safely and correctly. Number 3 objective is to recognize possible hazards and apply basic laboratory safety rules. Number 4, record observations clearly, neatly, and in the correct format for physics. Number 5, but not on the board, is use tables, units, and significant figures correctly when presenting results. And lastly, for this video, we'll write short but clear conclusions based on data. So sit tight, it's going to be a lot to cover in this video. Try and follow what we are doing. If you're not subscribed yet, subscribe to our channel to get exciting STEM videos. So we dive in. Conceptual explanation. So in physics experiments, experiments help us to test laws and view theories. The quality of your results depends on 3 things. Number 1 is apparatus, number 2 is safety, and number 3 is recording. So these are the 3 things that the quality of your result depends on in experiments. So what are the apparatus? The apparatus here is using the right instrument for the job. So we need to be using the right instrument for the job. So under safety, we will be preventing injuries and damage. So ability to prevent injury, there are some rules we need to follow to ensure that this is avoided. And recording is more important. If this experiment is not recorded, how do we now have a proof that it was carried out in the first place? So in recording, we should be presenting accurate and reliable data. We should be presenting accurate and reliable data. So all these are the things that we're going to be looking at. Good experimental work shows care. So it shows care, clarity, and correctness. So we'll go into common physics apparatus and their uses. The first one I have here is the meter rule. The meter rule. So the meter rule is used in measuring length of up to 1 meter. And key safety tips to use in the meter rule is that we should read at eye level to avoid parallax. So you read at eye level to avoid parallax your eye. This is what you are reading. Ensure that your eye is looking at the calibration directly at eye level to avoid parallax. So that is the safety usage tips for meter rule. Okay, so the next apparatus we use a lot in physics is vernier caliper. Okay, E-R-E-S. Okay, vernier calipers. So it's measuring small lengths of up to 1 to 15 cm. Very small lengths, 0 to 50 cm. So there is high precision here. There is high precision for vernier calipers. And if you want to use vernier calipers safely, so that you can get the accurate results, you handle it gently, read the main and the vernier scale. So it has 2 scales, the main and the vernier scales. Okay, so the third apparatus we majorly use in physics laboratories is the microscope gauge, the micro screw gauge. Okay, so the micro screw gauge measures very small thickness, e.g. wire, paper. Okay, so very small thickness. So how do we use it safely to get accurate results? Avoid tightening the spindle. Avoid tightening the spindle. Okay. So the next one is the stopwatch. The stopwatch. What comes to your mind when you hear stopwatch? Okay, so in physics we actually deal with timing sometimes to know the time there is the time reading for a particular parameter. So the stopwatch measures time intervals. So if you want to ensure that you use it without any problems safely, is to reset before each use. So safety tip for using stopwatch is to reset before each use. Okay. Then number 5 instrument is the thermometer. This is for temperature. Thermometer. This is for measuring temperature, and the key safety and usage tip is to hold vertically. When you're using the thermometer, hold it vertically. Yeah, so avoid rapid temperature changes. Just use it in a scenario where temperature change is gradual. Okay, so the next one we are looking at is the ammeter and the voltmeter together. Ammeter and the voltmeter. Okay, so this instrument is used for measuring current and voltage. When you come to electricity in physics, current and voltage. So what is the key safety or usage tip? So in order to use the ammeter or voltmeter, we must ensure that we observe correct polarity. Observe correct polarity. So if you are connecting the positive side, so this instrument is polarized. It's positive and negative. You have your screen like this, then the reader calibrated like this. So if the wire is coming from here, where the source of the wire, ensure it's coming from the positive source that connects it to the positive terminal, and the negative wire source is connected to the negative terminal. So observe correct polarity. Connect in correct positions. Okay, so there are also connections for series and parallel. So ensure that you make sure that you connect in series and parallel. Okay. Now the next one is the spring balance. The spring balance. This spring balance is used for measuring weights. Spring balance for measuring weights. For measuring weights or force. So key safety usage tip: ensure that it's 0 before using. 0 error. Just ensure that the reading is at 0 before you use it. Okay, so the next one is the rheostat. The rheostat. This is also for electricity. The rheostat is used for controlling current in the circuit. So the way this one is done is that it varies the resistance so that the current that is passing through each instance of variation of resistance is controlled. So you are controlling currents. So what are the key safety and usage tip? Handle by the insulated parts only. Handle it by the insulated part only. Okay, so still under electricity, we have the power supply. The power supply is another apparatus that we use. The power supply. So if you are asked to mention this in your IGCSE exams, you just list it the way I'm telling you now. It's providing current. The power supply provides current to your experiment. So key safety and usage tip is to ensure that you check the voltage reading you check the voltage rating, the stand, and ensure dry hands. Okay, and lastly, beaker or measuring cylinder. Beaker slash measuring cylinder. Okay, so there are times where you use this one for physics. You use it for holding or measuring liquids. Okay, so key safety and usage tip: Avoid hitting glass suddenly. Avoid hitting glass suddenly. Okay, so now having seen the different laboratory apparatus, let us look at laboratory safety essentials. That is, what are the things you need to know that to ensure that there is safety in the laboratory environment. So you need to know how to handle the environments carefully before the experiment, during the experiment, after the experiment. What are the safety tips that you need to keep? So before experiment, we need to, number one, check equipment for cracks or frayed wires. Check equipment for cracks and frayed wires. Okay. So before the experiment again, we need to know where safety equipment is, like the fire extinguisher. Know where the safety equipment is, e.g. your fire extinguisher. So in case there is a fire outbreak, you can quickly reach to the extinguisher and control that fire. Thirdly, before the experiment, tie black long hair and avoid loose clothing. That's why you wear lab coats. Tie your hair, for ladies who have long hair, or some guys that have long hair, tie back long hair, tie it to the back. Understand? Long hair. Why are we doing this? So that your hair does not interfere in the experiment. It doesn't interfere or catch fire or something. It's for your own safety and for the environment safety as well. So also avoid loose clothing. Okay, so this is before the experiment. Now, during the experiment, what do we observe? So during the experiment, the safety tips you can keep is to keep work area tidy. Number one, keep your work area tidy. Work area tidy. Ensure it's neat. It's neat. There's space in between your equipment. No necessary items on the bench, or no unnecessary items on the bench. So anything that you don't need, let it not be near you. Number two, during the experiment, never touch live electric parts with wet hands. Never touch live electric wires with wet hands. Okay, so you see this one now is very obvious. Then when hitting substances, point the open end away from yourself and others. The open end when hitting substances, pour the open end away. Okay, so when hitting substances, point the open end away from yourself and others. And lastly, for during the experiment, handle hot glassware with tongs and cloths. Don't use your hand to hold anything that is very hot. There's what they call tongs. So handle hot glassware with tongs or cloths. Okay. So after the experiment, your safety tips is switch off electrical equipment. So make sure that every electrical equipment is switched off. Don't leave it running. All electrical equipment. Secondly, Dispose materials safely. And thirdly, clean and return apparatus to storage. Clean and return apparatus, or apparatus that you have used, to storage. Okay, so this ensures that you have a safe environment. So the next thing we'll look at is recording observations. So how do you record observations? The essence of the experiment is to ensure that what you are seeing is put in a text form. It's put in a form that somebody else can read. Okay, so good data recording makes your experiments credible and easy to follow. Okay, so a well-designed result table should include, so the observation, it also includes tables. You understand? So there is a result table at the end of the experiment. So the result table should include the heading with quantities and units in brackets. So if I have the end of the experiment now, I'm doing my tables. For instance, let's say I'm measuring voltage and current. If I come here, I say volts. This is the heading for volts. In bracket, I put the unit voltage. You understand? And if I say current, in bracket, I put ampere. You understand? Well labeled, so that when I'm putting values 10.00, then 2.50, for instance. Everybody reading anything here knows that all this thing under this column is in voltage. So if I have something like 7.00 and 5.32, you know that this one is in voltage, this one is voltage, in current, sorry. So I will not come under this table or under this cell and be putting 10.00V, 7.00V. No. Why? Because the heading is already carrying the units. So headings with quantities and units in brackets. See, headings, then quantities and units in brackets. Then the neat columns aligned by decimal points. So all these columns aligned by decimal points. See how I put decimal points here? Okay, so all readings recording to consistent significant figures. So if you see that I'm using 2 decimal places here, and the figures are significant. This is one significant figure, 2 decimal points. You understand? So let it be consistent. Let it be neat, aligned by decimal point. So, and all readings should be recorded to consistent significant figures. Then a column for calculating values. So if, for instance, now I have done current and voltage, then if I want to do resistance, now for instance, I'll put a column here where I will say, V is equals to IR, right? Okay, so if I want to get R now for each of these readings, I will say R is equals to VI. So if I come here and then I say R is equals to V over I. So I'll put the units as ohm. This is a very good heading. And at the same time, it shows that if I divide, this one shows that if I divide this by this, I should get this. So you need to also put a column for calculated values. So I've listed 3 things that a well-designed results table can look like. Number 1, again, I'll go through. Number 1, that a well-designed result table should include, number 1, headings. You see, to include headings, then with quantities and units in bracket. This is the quantity, voltage, for instance, the unit of voltage in bracket. On that quantity, current, the unit of current in bracket. On that quantity, resistance. Now, this particular one is talking about the calculation, but resistance with quantity in bracket. Second thing that we need to know is that we need to have neat columns aligned by decimal points. Look at the neat columns aligned by decimal point. Understand? All readings should be consistent significant figures. And finally, a column for calculating the values. So I'll be giving you examples. So the tips under recording observation. Number 1, never write units in every cell. Don't write units in every cell. Don't come here. If I have this divided by this now, it's 4, for instance, 4.00. I cannot come here and come and put in ohm. Already there's ohm on the heading there. So don't write units in every cell. That's tip. Number 2, record all observed units. Record all observed units. Don't round up too early. So if, for instance, now I get things like this, 4.00, 4.23578. Let me just put it like that. So don't come and say 4.00 as round up. You can round it up to 2 decimal places, 4, for instance. At least you have cut off these ones, but you have these 2 already in your values. The best practice is to use 2 decimal place. That's the best practice, to use decimal place. But don't round it up to only 1 decimal place or 1 figure. So the third tip here is write directly into your table during the experiment, not from memory afterward. So you have a table, even if it's going to be a rough distance before you transfer it, have a table that you will write your observation directly to the table so that you don't forget what you are doing. Because you'll be doing different experiments, different instances. You'll be taking reading for this, this, and this. That's one instance. You take a reading again, you get this and this on that instance. Maybe you might have like 5 readings. You might have like 6 or 7. So why wait until you finish before you now say, okay, let me remember what I got from all these readings. So ensure that when you do your experiments, take your reading immediately. Okay. Okay, so I'm going to walk us through an example of an experimental case where we need to work on the results, work on the table. The task on the board here is to measure the time it takes a pendulum to swing, to complete 20 swings. So the apparatus we need for this particular kind of experiment is pendulum bob. The pendulum bob look like this. This is the bob with a string. So this is the bob, and this is the string. Then there's a stopwatch. It's a stopwatch. It's a stopwatch, calibrated like this. Okay. What else do we have? We have clamp. This is the clamp. The clamp looks like this. This clamp is to hold this bob and string. Okay. Then the protractor. The protractor is for measuring angle. You know protractor for measuring angle, right? That's how it looks like. Okay. Of course, it's calibrated again. Calibrated equal markings, right? To measure the angles. All right. So the procedure includes that by the time you fix this string here, then you take the bob. Let me fix the string. Okay, and the bob. So we're going to take this bob to one angle, to let's say 15 degree, small angle. Let me just do it. So you take it to this end. I did a broken line here to show that it's an instant. It's changing position from this to this. So you take it to this end and you leave it. So it swings like this. Please don't let it touch the rotor stand. I'm just doing a 2D demonstration. You swing it, it goes. So the swing goes, you release it, don't push, just release it. It goes 1, 2. You understand? It is the return that you count. The first one, 1, 2, 3, 4, 5, and so on until it gets to 20. When it gets to 20 swings, you time it. How many, what was the time for that 20 swing? You record it. Okay, you record it. Then you take another trial again and you also record it. You take a third trial and record it. Now, if your table will look like this. So I have trial. I have trial. I have time for 20 swings. All right, in seconds. See, in seconds. So you have the quantity and the units. Okay. Then the last one is period. So this period now is actually known as time divided by, that's what the calculation is. So the period is equals to small t over 20. And this one too is also in seconds. So you see how your table is. Just forget about my board representation, but when it's in your book, it should be neat. So you have trial. Trial is, I have 1, 2, let's say 3. Let me do 3 trials. So I'll do the first one. I'm not varying the length. I'm just doing trials, different trials. Okay. So I do the first one. I did the second one. I did the third one. When I did the first one, how many, what was the time duration for 20 swings? What was the time duration for 20 swings? Time for 20 swings. See? 20, then swings. What was the time I measured? Let's say I measured 2.6 seconds. I'm not going to be putting seconds here again. It doesn't make sense because I have seconds on. If I look at my table, I see the heading that is the seconds there. Okay. Second reading, second trial, I have 2.8. Third trial, I have 2.7. Note how I'm using everything in 3 figures. 1 decimal point, 3 figures. So it's neat, very neat. I'm not writing this one 8 here, then 8 here, then 2 here. This one is 2 decimal place, 1 decimal place. No, everything is uniform. You understand? It's neat, it's professional like that. Okay, so for the period actually is this time divided by 20. So if I put a value here, I know that whatever I am putting here is because I divided this one by 20. So if I divide this by 20 for the first one, I'm getting 1.63. If I divide 32.8 by 20, I'll be getting 1.64. And if I divide 32.7 by 20, I'll be getting 1.64 again. Okay, so with this one now, if I want to now, from my table, this is my record. We're talking about recording here. I have a very good record because every instance in the experiment I was putting my note. So if I want to now say average period from this my record, I can calculate average period. Average period is T is equals to the first trial is 1.63 plus second trial is 1.64 plus third trial 1.64 all over 3. That's average. Understand? So I'll be getting 1.64 seconds. So I have used this my record to get the average period for that particular activity. Okay. So how do we record observation notes? Observation notes. I have done this record of the experiment. I have recorded, put in scalar and in numbers what I am seeing from the experiment. So how do we record observations? So number 1, each measurement taken to 0.1 seconds stopwatch precision. This stopwatch, the precision is 0.1. So you see that my stopwatch is 2.1. I don't do it to I don't just write 32 here or 33. You understand? I can decide to write 33 because I have approximated, I have rounded up this to 33. That's by taking this 1, this 6 as 1 and added to this. No, but I am using this 0.6 because my stopwatch precision is 0.1. Okay. So then another observation note is that I should repeat readings. Repeated readings show small variation. So good reliability. See, this reading now, I did the first one. The second one again, the variation is just small. I'm not getting 32.6 first time, and I'm not getting 35. You understand? That could be huge. If that happens, it means that you should check yourself whether you're not trying, you're not doing it well. All right. Okay. So we have been able to cover all that has to do with this topic, this objective for this topic. I want to go through the videos and understand it. I'll be leaving some calculations or questions in the comment section for our engagement. You can go through them. Some of them have answers. Some of them you might need to go and find the answer by yourself. But I hope you will have a quality time with us, that you enjoy the video. I'd like to thank you for viewing.